Come, let's connect this airlift pump here. Teach us about the dishes above. Practicing making a hydraulic ram pump for the farm that requires no oil or electricity. To meet the water needs of the farm's fish pond and vegetable garden, we need an efficient and economical solution to divert fresh stream water into the fish pond and vegetable garden. Since it will be used long term, our team decided to consider cost savings, choosing to try making an airlift pump. We heard that an airlift pump can push water up to dozens of meters high without extra manpower. It perfectly meets the long-term needs of our budget-friendly farm. Installing a pump that requires no oil or electricity. Can it really pump water up? Can it pump water for irrigation? Irrigation, my foot. You two bachelors think you can pump water? Yeah. No electricity, no fuel. Can it pump hot water? This is a hydraulic ram pump. Once the water hammer effect is strong enough, it can push water up. I don't want to waste time learning this. Just wait, I'll show you in a bit. Do you believe it? As long as I set it up, it'll work. Alright, stand firm. Not bad, right? Look at our water flow, pretty decent. No fuel, no electricity, yet it pumps this much water. Impressive. At first, we built a simple model to test the feasibility of the hydraulic ram pump. The test results showed low pressure and small water output. Uncle mocked us ruthlessly. So we scraped together materials and built a 1-inch hydraulic ram pump. After installation, it looked quite powerful. We originally wanted to show off in front of Uncle, but instead, we decided to check the water output first. Let's show everyone how much water our hydraulic ram pump produces. The output was still small, and Uncle mocked us again. Friends, does anyone know what went wrong? Tomorrow, we're going all in to make it work. Using a liquefied gas tank as a pressure chamber, we'll build an extra large hydraulic pump. Let's see if it can meet the needs of replacing water in the fish pond. Can we successfully build a water hammer pump that can pump water without using oil or electricity? Previously, our farm aimed to make irrigation more convenient and replace fish pond water at the lowest cost. Considering the distance and location between the west ditch and our fish pond, we built several water pumps. All of them were too small in size. They could not take on the responsibility of keeping the fish pond supplied with fresh water. During the process of assembling and testing small water pumps, everyone gained a clear understanding of how the water hammer pump works. Moshe decided to go big and make a breakthrough. Using some discarded materials, he manually welded an oversized water hammer pump. Let's see if this can significantly increase its water output. Here are the iron balls and iron wires we bought from the scrapyard today. These are the materials needed to build the oversized water pump. Due to the lack of professional mechanical processing equipment, our precision in processing is almost non-existent. Fortunately, the core structure of the water hammer pump is not professional welder. Moshe has everything planned out in his mind. He is making it completely from scratch. Right now, he's building a one-way valve. Is this some kind of steel baby? This is a component of the drainage valve, a part of the drainage system. We'll spray a layer of light-colored paint on it. After all, a coat of white can cover up many flaws. Many friends in the comments section mentioned that our previous water pump's inlet pipe was too small. This time, we bought to 110mm PVC pipes for testing. 87 yuan, 80 yuan. All our stuff was already paid for. Like how I celebrated the new year. Oh, just like how I celebrated the new year. Are you getting married? Kai Tai He. We gathered all our friends and headed to the west ditch for testing. Here, we attached an adjustable elbow pipe. Hey, press it down. Wait for the air to be expelled. Wait for all the air to be discharged. Wait a moment. Now, after adding the weight of these two bricks, It will start hammering. It will start hammering. But the pressure
There is a
tank. One-way valve inside, but since it was handmade. Look at the current pressure. The pressure gauge shows no increase. We suspect that because this one-way valve is handmade, it is not properly sealed. When draining water, the seal isn't tight and water leaks so
back
the pressure cannot build up. So this handmade one-way valve is not working well. Are there any friends familiar with the working principles of water hammer pumps? Do you think the issue could be caused by other factors? The hammering works, but there's no pressure in the air chamber. Please share your thoughts in the comments once our new pre-made one-way valve arrives. We will try to optimize and fix all potential issues at once. Can we successfully build a water hammer pump that replaces fish pond water without using electricity or fuel? Oh no. Oh no, oh no. What is happening here? Right now, our water hammer pump is failing because the handmade check valve is leaking air. The pressure built up in the air pipe is leaking straight back. Without pressure buildup, it doesn't work. Recently, the fish fry in the pond have also arrived. The task of using the water hammer pump to introduce fresh stream water into the pond has become even more urgent. The newly purchased commercial check valve has arrived. Let's quickly install it and see if it solves the pressure buildup problem. Start. Ha. There's no pressure at all, fat guy. A little. You don't understand. It won't work. I don't get it. I completely don't get it. This is the water flow we have now, but it still doesn't work. It won't function. Look at this. It's already dark. We've been at this until nightfall. It's trying to work on its own. Still not perfect. The pressure gauge still shows nothing at all. After an entire day of testing, it's the exact same issue as before. No pressure in the pressure tank. Today, we're going to try a new location with submerged water flow. We'll eliminate the possibility that an air leak in the intake pipe is causing the failure. To make testing easier, we're installing a valve and a quick connect fitting on the intake. Oh fly, baby. Any pressure when hitting it? Oh no. What is happening? The hammering force is too strong. The glue joint was directly knocked loose. We'll re-glue it and secure it with a stopper at the end. Temporary fix complete. This gauge is still unsatisfactory. After so many tests and modifications, the pressure gauge still shows nothing at all. Honestly, I'm starting to doubt our DIY skills. Can we really build this large-scale water hammer pump? But thankfully, a water pump expert from the comments section has been guiding us through the problem-solving process. He suggested that we should avoid using a siphon intake method for the water pump. So this time, we dug a small water pit, letting the intake pipe naturally draw water. We used an electric pump to continuously fill the pit for testing. Another round of disassembly, adjustments, and reassembly. We've tried so many locations this time, no siphon method. Siphon method eliminated. Still can't build up pressure. Maybe the issue is, right now, we're feeling lost. We've dug a reservoir pit at the upper position. Now we're pumping water up to see if we can build pressure. Let me show you the setup above. We've enclosed the top area. Then, we pump water up and test it here. Testing it here. Look, right now, it's hammering normally. Now it's hammering properly. Even the end cap can't hold it anymore. The hammering force is really strong. Finally, some pressure has built up. Looks like that old method really didn't work. Clearly, the previous approach was ineffective. Now we've reached nearly 0.2 bars of pressure. Water is coming through. It's flowing. Look at this, everyone. So much water, such a huge flow. This is good. The water flow is really strong. It's filling the entire pipe, completely full pipe. There's even enough pressure to push it higher. With a 2-meter intake height difference, theoretically, it could reach nearly 20 meters. However, both the efficiency and output flow still have significant room for optimization. Friends, if you have any improvement suggestions, let us know in the comments. In the next episode, we hope to install it in place. Previously, we manually created an intake environment to test the water pump. We successfully built up 0.2 bars of pressure in the pressure tank. The conclusion is that the water hammer pump intake cannot use a breathing method. Since the test results are barely sufficient, we'll finalize the installation in the drainage ditch below the fish pond. Let's show you the installation location of our water god Phoenix. This is the intake point. Our fish pond is up there. It's about 14 to 15 meters above. Previously, since it was just a test, the water hammer pump wasn't fixed. This time, we're preparing it for long-term use. We will secure it directly to the rock with expansion bolts for reinforcement. Now reinforcing and securing it, installing the expansion bolts. The hammering force is extremely strong. Looks good. Pump it 28. Look at you spending all day watching videos. Why not watch our own videos? Instead, you keep watching random ones. If you had watched just one, you'd know we specifically pump water to the fish pond. Now, take a look at the intake area we're working on. We're raising the enclosure. A greater water level drop will increase the hammering force. Now, let's take another look at the surroundings. This is Chinese thorough wax. It can clear phlegm, aid digestion, and refresh the mind. If eaten regularly, could it make us smarter? This is Asotis root. Yes, the famous Asotis root herb. And this here. This is Lysimachia. It helps cool the body and relieve heat. Our farm friends relied on this to survive the summer heat. As far as the eye can see, there are medicinal herbs everywhere. Our field looks like an open-air herbal medicine treasure trove. There are many I don't even recognize. Alright, enough talk, let's get to work. The fish in the pond must be eager to drink this medicinal soup of Zihu herbs. Since this is now finalized installation, all component gaskets must be installed properly to prevent leaks. Finally, we install the pressure tank and time to start pumping. Getting ready, start hammering. No problem, no problem. It's running normally. Look, our water pump is now operating smoothly. The current pressure just barely reaches the upper fish pond. That's our intake point. But the intake height is quite low. It's about 2 meters over there. Then it flows here. And our fish pond is up there. Let's go check the water flow at the fish pond. It's at 2/3 of the expected volume. Quite a lot. Right now, our pump is just enough for the fish pond. Supplying the pond is its maximum capacity. If we want to pump water to the sheep pen, we need an additional 20 meters of lift. Next episode, we'll add a discharge valve to see if we can double the hammering force. We might achieve twice the lift. Oh ho, its hammering frequency is completely different. It's hammering chaotically. Building a hydraulic ram pump to provide the farm's fish pond and sheep pen with a continuous 24-hour free water supply. Will it be successful? The corners are twisted, strangled, and still so itchy. Why is it so itchy? Previously, we had already built a hydraulic ram pump and successfully pumped water. However, its lift height was only 20 meters. To supply water to the sheep pen, we need to double the lift height. So this time, we're making a new hydraulic ram pump, designing it with 2 additional waste valves to increase its hammering force. Let's see if it can reach a 40-meter lift height. With previous experience, this time, material preparation was much smoother. The intake pipe, pump body, and pressure tank were all scavenged. We picked them up from the recycling station in one go. The handmade waste valve from last time had a complex structure. Its machining accuracy was poor. This resulted in relatively low efficiency. This time, we simplified the structure, increased its precision. Not only do we hope to improve efficiency, but also to make it easier for interested people to replicate. In the future, anyone can easily recreate it in a small village. Don't let it just explode randomly left and right. Of course, the previous intake installation had only a 1.6 meter height difference. Reaching a 40-meter lift was unrealistic. So we chose another location with a 2.5 meter intake drop for installation. This way, we only need 16 times the lift ratio to easily reach 40 meters. Take a look at this location. It rained last night. As the saying goes, when you ask about my return, I have no answer. The night rain of Mount Boss swells the autumn. It's as if asking when you all will come across this video. Our anticipation is just like this autumn rain, filling up this water pool. In short, after a few days of work in our spare time, the intake pipe has been mostly set up. You installed it without testing it first. You have to test it before installing. What if it doesn't pump water? Let's see how you explain that. This time, we skipped testing and went straight to installation. Overconfident. If it fails to pump water, changing locations will be difficult. So will it work? Everything depends on this. Let's hurry up and complete the final installation. Oh right, before installing the pressure tank, let's add an air bladder. This will prevent the issue of decreased water flow after prolonged use of the hydraulic ram pump. I'm so hard. HMPH, So you're saying we're not doing a test and just fixing it in place first, huh? The connection key for the outlet pressure gauge is missing, so we'll block it with a valve first to see if the hydraulic ram pump can hammer properly. Come on, let's run a water test. Hey, what's going on? Why isn't it leaking? Oh no, this isn't working. This isn't fixed properly. Look at this. Hey. Manually hold it in place, and then it should work. Just poke it a bit, and it'll drop into place and start hammering. Yeah, it wasn't secured properly. But the effect should be fine. Come on, let's poke it a few more times. Go. Oh, it's running automatically now. Hey, now we don't need to poke it anymore. Once there's pressure in the tank, no need to poke it. Hey, not bad. Feels like it worked as soon as we tested it. Oh no, something's going wrong. It's out of sync. This definitely isn't right. Or is it because the pressure in our tank is too high? Open it fully and check. Hurry, release it. If the pressure in the tank is too high, the hammering frequency will be off. Manually priming a ram pump was never going to work perfectly on the first try. But it's already getting dark. We'll have to wait until the next episode when the parts arrive. Then we'll install the pressure gauge and see if the tank can maintain 0 point for megapascals. We should be able to reach around 40 meters of lift.